As you can see on the screen, we've got a quadratic equation. And one of the first things we want to be able to do with quadratic equations is actually graph them. We'll spend a lot of time also discussing things like how to find zeros or how to find the vertex. But the biggest thing is we need to understand the basic shape of a quadratic equation and understand that it's going to give us what we call a parabola or a parabolic shape, basically a U shape, infinitely going out left and right, but traveling either up or down with a vertex at the bottom and an axis of symmetry running through the middle, which we have described at the bottom. The axis of symmetry is the vertical line that's going to run directly through the vertex, cutting our parabola in perfect half. Now, one of the simplest ways to graph any function is to remember that you can just take x values and plug them into your equation, such as saying that negative 2 squared minus 6 times negative 2 plus 7 will come out to 4 plus 12 is 16, plus 7 is going to be 23. Now, unfortunately, 23 is probably larger than what we need to graph, so we want to continue on and keep on plugging in points, such as negative 1 squared, which will be 1, plus 6, negative 6 times negative 1, so 1 plus 6 is 7, plus another 7 is 14, and we're getting much more graphable or much smaller. So let's see if we get small enough that we can actually go ahead and count by 1s. Otherwise, we can always count by 2s or 3s and include the points that we've been finding. Go ahead and take the rest of the points on this table, plug them into your function. I'm going to pause the video now, and then you can go ahead and fill in the table, and I'll pick it back up when we have the table done. Alright, you'll notice that the table is now filled in. Also, hopefully you noticed toward the end of your table that we started to get essentially what we're going to be calling some symmetry. We ended up here at negative 2 for our output, and then notice right above that was negative 1, right below that was negative 1. Also above and below that were 2 and 2. So when we go to plot our points, I would go ahead and start with that middle point. Start with what we're going to call the vertex, knowing that that's that middle point in between all of our symmetry. 3, negative 2 is plotted right here. Then we can plot 2, negative 1 and 4, negative 1, as well as plotting 1, 2 and 5, 2. If you want to, you go ahead and graph farther. 0, 7 was also a very plottable point. And although we didn't find it, notice that that symmetry is sort of happening. If we draw our axis of symmetry in, that point that's going to run again vertically directly through our vertex there, you'll see that we're 1 point to the side of our line of symmetry here, 2 points when we're up at y equals 2, 3 points when we're up at 7, so I can move 3 points to the right and use that symmetry to plot more points. Then notice we get that nice parabola as smoothly as we can. I'm going to go ahead and try to regraph that, see if I can't draw it a little bit more smoothly. We want to try to make that look like as smooth a U shape as we can. And then don't forget your arrows, as it does infinitely keep on going out to the right and out to the left as it travels upwards. Again, your vertex is going to be that point right at the bottom there, also known as your minimum value point or your minimum point, but that's a nice parabola. Now, instead of having to plot points by doing lots of large tables, knowing where that vertex was could have saved us a lot of time. We wouldn't have had to find all those extra points that we couldn't use. So in standard form, y equals ax squared plus bx plus c, one quick way to find the vertex is to use the equation x equals negative b over 2a. So we can say x equals negative b, b being the middle coefficient here, the coefficient of x to the first. So negative of negative 3 is a positive 3, over 2 times a being 1/2, the coefficient of x squared. 2 times a half is 1, and we quickly find out that the x-coordinate of 3 is going to be our vertex. Well, that gives us a middle point to start from. So now we do have to go through the good old-fashioned route of plugging 3 into our equation, which I'll let you do in just a second. But first, let's find some other good x values. If 3 is going to be a good middle point, why don't we go ahead and also find 2 and 1, as well as 4 and 5, giving us 5 solid points once we fill in that table. Again, take a second, fill in the table, and I'll be back with you when we have the answers. Alright, you'll notice that I filled in all my y values, found that my vertex is at 3, 1/2. Also plotted the points at 4, 1 and 2, 1, and 5, 2.5, 1, 2.5. Again, getting that perfect symmetry around our axis of symmetry at x equals 3. Don't forget to label your graph. You can either label the fact that the top of our graph ends at 5, or just label that first tick mark, calling that 1. But make sure you label both your x and y axes so you know what you're counting by. Again, the axis of symmetry also just happens to be the x-coordinate of the vertex, so that equation of x equals negative b over 2a actually helps you in two different ways, finding you not only the x-coordinate of the vertex, but also finding the axis of symmetry. Now, sometimes an equation won't start off in standard form, so the first thing that we're going to want to do is go ahead and separate those two sets of that factor, x minus 2 times x minus 2, FOIL that together, and then combine some like terms so we can get ourselves into standard form. Once you've got that, now we can jump to finding our vertex, or at least the x-coordinate of. So negative b, again solid positive 4, over 2 times a, so 2 times 1, and we'll find that we want to start our table at 2, thus using 3 and 4, as well as 1 and 0 on our table. Go ahead again, I'm going to pause the video. Find the y-coordinates, whether you plug them back into your standard form equation, or you could also plug them back into your other form up here with the x minus 2 squared factor up there. We'll call that vertex form here pretty soon. But for now, either one of those will work. Go ahead and find all your y-coordinates. Plot them, and then we'll talk a little bit more about minimum values. Alright, since that middle point on our table, we went ahead and made sure that was our vertex. We can label that here. You could also label that on your graph, calling it the vertex. Or you could always a good idea to go ahead and list off the fact that it was at 2, 1 as well. Notice I've labeled my x and y axes, plotted my points, and we get that nice symmetrical looking graph again. Identify the minimum value, remember, is going to be the y-coordinate at its lowest spot. Since our parabola is opening up, the lowest that we ever went was y equals 1. So just realize that when they say minimum value, they're talking about what's the minimum value of the output of the y-coordinate. Don't actually give the entire vertex, because remember 2 isn't technically a minimum value, as we can go farther to the right or to the left of that coordinate. It's the y-coordinate that we're talking about. Now, one helpful shortcut for graphing parabolas is also to think about the basic shape. There's what's called the 1, 3, 5, 7 method, and sometimes that's a very helpful way to quickly find the shape of your parabola. You'll notice that the vertex on this one, because b is equal to 0, then negative b over 2a, well, we're going to have 0 divided by 2 times 1. Essentially, our x-coordinate will be 0. For a basic y equals x squared, as simple a quadratic equation as we can get, you're going to have a 0 for x, and 0 squared will be 0 for y as well. You get to start that vertex right at the origin. Now, the 1, 3, 5, 7 method basically says if we start talking about the first numbers that we can plug into a table, well, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Notice that they go up from 0, 0, up 1 unit, up 3 units, up 5 units, and up 7 units. The perfect squares are separated by basically counting the odd numbers in order. So instead of having to find all of those points and not actually needing that whole table, we could have actually just said, well, from 0, 0, I want to go up 1, then up 3, then up 5 coordinates as I move to the right on my graph, and also go up 1, 3, and 5 units to the left. And you'll notice we get a nice smooth, assuming I can draw this smooth line here, graph of a parabola, labeled nicely, of course, and you've got your graph. The only thing we haven't put on there is the axis of symmetry, but again, once you know the vertex, you can just draw that line down the middle right where the y-axis is. Now, if it's not a 1 for an a value on the front there, in just a second, I'm going to fix our screen real quick. And there we go. Again, if we don't have a 1 for an a value, well, all that happens is, remember that that's a vertical stretch on our graph. We worked at the same thing when we talked about absolute values, or a little bit when we talked about other graphs. We're stretching. We're taking all of our outputs after we've squared it and multiplying them by 2. So we're going to be twice as far from the x-axis. Well, again, if we do negative b when b equals 0, well, b is 0 divided by 2a, so we get 0. 0 squared times 2 is still 0. And remember, even though we're doubled, 0 doubled is still just 0. So we're going to start at 0, 0 for this graph. Then, instead of going up 1, 3, 5, 7, we need to double that, as we note here over on the right. If a is not 1, then the y values around the vertex will increase by a, 3a, 5a, 7a. So the 1, 3, 5, 7 method can still be used. Well, since a is 2, I'm going to go up 2 units, then 3 times 2, which would have been 6, so I'm going up to 8. And notice after that, we're going to be off our graph. Then I can use my symmetry and do the same thing to the left. 2 units, 6 units, then I would have to go another 10 units. And again, if you connect those points as smoothly on a parabola as you can, not very smooth there, but you probably improve on that, we get a nice graph. And again, don't forget to label your axis so that we know you're counting by ones. Whether you label the last line or the first line doesn't really matter, but do that labeling. Good luck. I hope that helps you graph basic parabolas, and we'll give you some more hints here to come. Have a great day.